Buddy, welcome back to iBuddy Science, and today we're going to be doing Intro to Circuits. Now, Intro to Circuits, we have a couple of terms that you must know before we do this. Now, in circuits, the main things that we have to consider, and the main three things that we're learning, is what voltages, what resistances, and what current is. So, what we're going to start off with is we're going to start off with some key terms, as I said. So let's start off with current. Current is the amount of flow of electrical charges. Resistance is the degree of which substances oppose the flow of electrical charge. And circuit is a closed pathway that allows electrical charges to flow. A load is a device that controls electrical energy into another type of energy. Voltage or potential difference is the difference in electrical potential energy between 2 points that will cause the current to flow in a closed circuit. Current electricity is the continuous flow of electrons in a circuit, and static electricity is electrical charge that builds up on a surface on an object. Now, before you guys get really complicated with all these terms, don't worry, I'll re-explain them later on in the slideshow, and you'll slowly start to understand how they're used in applications. So let's start off with what's happening. So I'm going to start off with something pretty simple, okay? Circuits, right? What are three objects that have circuits? So I want you guys to think for a little bit. So for me, what I would say is a phone, for example. We have the motherboard of a PC, or for instance, we have the controller of a chip. So there's a lot of things that use circuits. Pretty much all technology, most technologies use circuits nowadays in modern tech and our innovative world. So here are some of these definitions from earlier. Electricity is buildup, which is static, or movement, which is current of charged particles, and these particles have electrical energy. Now, the first thing you have to understand is that electricity is sort of an umbrella term, or it's sort of it contains and houses two different subcategories in it. Electricity can either mean static, or electricity can mean the actual movement. And as explained in another lesson, or in the previous lesson, the movement is what current electricity is, while electrical and static electricity is that electrical charge building up on a surface. So that could be when you get electric shock, for example, there's these electric charges that cause a difference that causes a shock, and that's what static electricity is. And electricity houses this term, and electricity is also this term. So electricity has both of these terms under it. So this is the big term, and these are the smaller subterms, static and current. So this is the important one. These are the smaller ones. So now we have current. I want to talk a little bit about two types of current. We have direct current, which means that the electrons flow in one single direction. Now there's also something really interesting here called conventional current. And this is because pre-modern science with electron flow, they use conventional current to calculate. And that's what we typically use nowadays to calculate. So conventional current is the more usable one. Now, alternating current means that the electrons flow and then they come back. Now, in this image, it's supposed to be a GIF actually. It didn't actually, I don't know why it didn't go. But basically, in direct current, it's just going this way. It's just going like, okay. Well, for here, it's going like, it goes and then it comes back. And it goes and then it comes back. And that is what's basically happening here. And it does that all the way throughout. And as here, that's how it works. Now, it's supposed to show the electrons going forward and then going backwards. It's supposed to show a movement of these electrons going forward and backwards. Now, it didn't show it here. I don't know why, but these diagrams are supposed to show that. But as you see here, we have alternating and direct current. Direct means one way, alternating means both ways. And then conventional just means how pre-modern science physicists basically calculated different things in a circuit. So static electricity versus current electricity. These are things that are pretty interesting, to say the least. Essentially, current electricity is under here, DC and AC, and that's pretty much all you have to know for this. Alright, now let's do some circuit diagrams. So here, we actually have a diagram here, and what we're seeing here is that we need to label these. This first one here we see is that there's these resistors all in one singular line, and there's three of them. So what we can know here is that these are in series because they're right beside each other. as you hear, they have direct connections. This one here is parallel because the battery is on this side and there's these things that are parallel to each other, the resistors. And this is essentially what's called a parallel circuit. And these two are fundamentally different in the way that the resistance, the current, and the voltage functions in a lot of different ways. Sometimes they can be combined in combined circuits where series and parallel can come together. And that's where the hardest part of this unit really is. So let's go a little bit more into what the difference is between the series, which is this one because the current goes straight through and it's in one path, and parallel, which is multiple paths. So let's go down to the next slide. Series circuits have only one path along which electrons can flow, while parallel circuits have more than one path along the electrons where it can flow. So that's essentially what I said earlier. It can go here, it can go here, while this one, it can only go here. And this changes the fundamentals. And as here, yeah, the same thing I mentioned earlier. These combinations are called combined circuits. So here we see series and we see parallel. There's two lines compared to just one fluid line. Alright, so let's go on some learning goals. I can identify the components of simple circuits. I can explain the movement of electrons in a simple circuit, an electrical circuit. I can identify the symbols. I can draw circuit diagrams, and I can construct circuits from circuit diagrams. Alright, what are the parts of a circuit? Let's get on with it. Is this a circuit? So, I would say it is a circuit. Is it a complete path? I would say, yeah, because there's connections. So essentially in a circuit, you must make sure that the electrons have a complete path to the positive cathode compared to the negative cathode. And the cathodes are basically these things. Now, why does voltage really work? And it's mainly because this side has a lot of negatives. So let's imagine a lot of negatives here. And this side has a lot of those positives. So what happens is that there's a difference between this part of the current circuit compared to this part. So the electrons, because we know that negative particles are attracted to positive ones, they're gonna go this way, and they're gonna combine with this one. And that's basically why voltage is sometimes considered as potential difference, because it's the difference between the positive and the negative ends of the battery, which allow it to move through. Because in negatives, the electrons really want to go to that positive side. So that's what creates that electricity, and that's what actually creates that movement of electrons. So what are the parts of the circuit now? Well, the parts of the circuit are, well, we have a battery, we have a wire, typically made out of materials such as copper, we have a load, and that's pretty much it. These wires are formerly known as conductors, which is the more scientifically term. But let me explain what each of these things do. So the battery, what it should do is it creates that potential difference. As I mentioned earlier, that's what creates that voltage. The conductor is just allows electrons to flow. Other materials do not have this capability, which is why copper is one of the best ones. Now, a load is basically a device that can convert electrical energy to other forms of energy. So here's electrical energy going to this, and it converts it into light energy. But is there any other energy that you guys think the light converts it to? Well, that would be heat energy. It also converts it into heat. So, what are the parts of a circuit? Now, all circuits must have an energy source, conductor, and load, as I mentioned. These are basically the what they are and what they do. So as I already mentioned all this, so what are some other examples for some loads? Off the top of my head, I can think of a lot. So one, for an example, it could be a switch, or it could be a calculator or something like stupid, right? It just needs voltage, and it can do that, and then it goes to the other side of the battery. Like pretty much anything is a load, an LED, a screen, LEDs, all that. So what else? What's the way to open or close the circuit, and what are some safety features? Alright, let's go here. This is a terminal, part of a battery or cell that's connected to the rest of the circuit. We have another optional part. So these are basically just terms to know. This part is like negative, positive ends. Now, optional parts of an electrical circuit, there's a switch that can complete or close or break it depending on which way it's connected. So we also have that. There's also other optional parts such as resistors, which basically slow the current flow. So here's a fuse, which I briefly mentioned in the last lesson. I give you a glimpse of it, but it melts when current becomes dangerous. So essentially what happens is that when there's a lot of current that's coming, the 13 amps, it can only handle 13 amps. So the fuse that's 13 amps, when 13 amps is exceeded, the entire thing burns apart. And this is a very important part in a lot of applications because that basically opens the circuit and doesn't allow electrical energy to go through. Now another thing is a circuit breaker, and this can automatically open if there's short circuiting or if the current's dangerous, and these are safety features to prevent fires. I mentioned this briefly in the last lesson too, so if you guys haven't watched that, that's very interesting and it could give you a better glimpse of this lesson if you're confused. So try it yourself. Now, this is obviously what you're going to do in class. What I would recommend is just take a switch, take something, and put it all together. Take the battery and create those, and take a conductor and create a nice circuit. So open and close circuits. Open circuits, they contain a gap or break. So for example, if we have a circuit like this, here's our battery. Let me draw a better battery. We have a battery, we have something like that, but it doesn't go there. That means it's an open circuit. But if I were to connect it, that would mean it's closed, as it's now allowing electrons to move through. So for example, if you break the filament of an incandescent light bulb, the electricity will escape. Now a closed circuit is where it has a complete path. So when electrons flow, this is open and the flow of electrons stops. It flows when it's closed, but when it's open, it stops. So what are some different types of circuits? Alright, so the first type of circuit, we've already mentioned these, series and parallel. Series has one path, parallel has multiple paths. So that's mainly the main indicator of its series or parallel. And now if you deleted everything here, if you only had this section, this would be series, because you have this. There's only one path, but if you added this, then that's a parallel circuit. So electrical quantities. Now, what are electrical quantities? Basically, they're just voltage, resistance, and current. That's basically what electrical quantities are. So you guys have a handbook probably in class, so what I'm going to be showing you guys is how to complete it. So in a series circuit, the current is same, while in the parallel circuit, it will divide into different paths. Now also in a series circuit, the resistance adds in series, while in a parallel circuit, it decreases in series. This one divides, so let's write that down. Divides. This one is the same. In series circuit, the resistance adds up, while it decreases in the resistance. Voltage will use part of the load, while in parallel, loads will use all. So here, let's ask you guys a question. Is it series or parallel? If you said parallel, then you would be right, because these are in parallel. These guys are in series. So yeah, inside this is actually a combined circuit that we'll be going into more depth in later. But here we have the parallel circuit, and then we have the series circuit, and we have it another parallel. So this entire thing is parallel. But then we have two light bulbs here that are actually in series. So this is a combined circuit. It's not actually either or series or parallel.